We want to write functions to model the given situations below. The first one is a polynomial with different n behavior that has exactly 3 roots and hits the x-axis at only the point -1, 0. So the first part is the different n behavior. That means it has to be an odd degree polynomial. So I would need an odd number of factors. It has exactly 3 roots. So right there I know that it must be a third degree polynomial. And it hits the x-axis at only the point -1, 0, meaning that its only root is at -1. So my function, I'll call it f of x, can only have one factor, x plus 1, because that will give me the root -1. It must be a third degree because it has exactly 3 roots. It just so happens that they're of degree 3. A polynomial with the same n behavior and 5 linear factors. So if it has the same n behavior, that means that it is an even degree polynomial, and it has 5 linear factors. And I guess this is a little ambiguous when I say 5 linear factors. The term there is that there are 5 distinct linear factors, so that should be included. Distinct linear factors, meaning that there are 5 different factors, but this obviously has to be an even degree polynomial. So once again, what I would do is I would know that I have to have 5 linear factors, whatever it is that you choose them to be. And because it has to be an even degree polynomial, well, 5 linear factors would make it odd. But if I were to square one of them, all of a sudden it becomes a 6th degree polynomial, and everything works out again. A 4th degree polynomial that touches the x-axis only twice. So if it hits the x-axis only twice, that means there can only be 2 places where it hits the x-axis, in other words 2 roots that are in effect. And so that means that both my linear factors, because each linear factor will give me a particular root, well, they both must be different, so perhaps x minus 1 and x plus 1. But they both must be squared because this is a 4th degree polynomial. And finally, the last one is false, cannot possibly happen. And I want you to figure that one out on your own. You can do it.